Lesson 20, Interpreting Truth Tables. So we're going to begin by just recalling some information that you guys already know. A conditional statement is if P, then Q, where P is the hypothesis, Q is the conclusion. The converse of a conditional statement is if Q, then P, and that's where we switch and do if the conclusion of the original conditional statement, then the hypothesis. And the inverse of a conditional statement is if not P, then not Q. The contrapositive is if not Q, then not P. Today we're learning what a biconditional statement is. It's basically two statements written as one. So it's a combination of both the conditional statement and its converse. And the way we write that is we say if, no, we don't say if. Where is my layout? You just start with the hypothesis. So you say the hypothesis, if and only if Q, and then you state your conclusion. We can write P in a double arrow. So instead of writing if and only if in your statement, you actually can do the double arrow. Or you can do IFF, if and only if. So biconditional statements are only true if both the conditional statement and its converse are true. So we could say students get an A in middle school if and only if they have 94% or above. So it's the statement would be if a student gets an A, then they had 94% or above, and the converse would be if a student has 94% or above, then they will have an A. So that's true for both statements. So if P and Q have the same truth value, so I guess I think that means that if they're both false, wait a minute, then it could be true. Wait. No, you're not going to have a statement where both the statement and the converse are false. Never mind. Can't do that. But you could have the hypothesis and the conclusion are both false, and the biconditional statement would still be true. Okay, I'll show you in a truth table when we get to truth table. So this is what we're going to go over today. Truth tables are a list of all possible combinations of truth values for a hypothesis and conclusion. So we're going to write down what that is. So truth tables are a list all possible combinations of truth values for a hypothesis and conclusion. And the conditional statements they have. So the beginning, to start a truth table, it always starts the same way. So we have our table. The first two columns will be the same every time you write a truth table. You write the P, then the Q, and the first column would be true, true, false, false. And the second column will be true, false, true, false. These are all the ways that a hypothesis and conclusion could go together. If the hypothesis is true and the conclusion is true, or the hypothesis is true and the conclusion is false, false, true, false, false. And then you look at that and you can think, if P, then Q. So if the hypothesis is true and the conclusion is true, then the statement will be true. And one thing to know, this conditional statement is only false if the hypothesis is true and the conclusion is false. So you can fill in a false here and then the rest will be true. So we're going to do a table for if and only if. So is this really confusing?
Yeah, it's just looking at the bottom one, it has two falses, so that.
Do you remember that in the conditional statement, if the hypothesis and the conclusion are both false, then the statement itself is true? Do you remember that? Like, if elephants have baby whales for offspring, then the baby whales are pink. That's a true statement. Because they're both false. And it's not going to happen. I know that was like a way out there statement. Okay, I want to show you an if and only if truth table. So it doesn't matter what the statements are. The truth table helps you see. You'll be able to then figure out if the truth value is true or false using the table. So we're going to start with P, Q. Remember, the hypothesis can be true or false, so we put down all the ways the two could go together, true, true, false, false, and then true, false, true, false. The statement, if P, then Q, we already know is only false when the hypothesis is true and the conclusion is false. The rest are true. And then if we do the converse, so if Q, then P, we have to look at it backwards. So the only time this statement will be false is if Q, the conclusion, is true and P, the hypothesis, is false. So we're looking at when Q is true and we're trying to find when P is false. And that's this column right, or this row right here. So this one will be false and the rest will be true. And then the if and only if, so P, if and only if Q is only true when both the conditional statement and the converse are true. So you can see that these two are true, those two are true, which means these two will be false. Oh. Truth tables can be super helpful because Dixon, you're lost. Did you understand this first one? Like that it's only false if the hypothesis is true and the conclusion is false.
So they have to be matching to be true.
No.
Yeah.
No.
No. Only false when the first one's true and the second one's false. The rest can be true. Will be true.
Why can't this
Okay.
And then when you switch it around, you're looking at this one first and that one's second. So remember it was false when the first one's true and the second one's false? But now we're looking at this one. So when this is true and P is false, then that statement will be false and the rest will be true. Okay? And then when we do P if and only if Q, we have to look at these two right here. And it's only true when both of those are true. Yes, Harrison.
So, did you make up the truth, false thing, or is that like how it works?
This is standard for truth tables, yes, because this is for any statement, any conditional statement. So you can do the converse, the inverse, the contrapositive, you can do all of that in a truth table without even knowing what the statement is yet. So once you have your truth table, then you can plug in a statement. So if it is Thanksgiving, then it is Thursday. So that's true. But then if you said if it is Thursday, then it is Thanksgiving, that statement's false. So the if and only if would be false. It wouldn't be a true. You couldn't use the biconditional statement for that one. Yes.
So is each row kind of like the order of them is the statement and then the converse and then the inverse and then the contrapositive on the order of the rows?
Not necessarily. I usually will put in these three no matter what. So if
Okay.
I'm doing a truth table, I like to have these three. Well, actually, maybe just these two. Sometimes you'll have a not P and a not Q. So if it's not P, then your column will read false, false, true, true. And if it's not Q, it will read false, true, false, true. So, so sometimes you have those in there to help you with your table. We'll do lots of practice on these. There's a couple other vocab words that I want to teach you. And they go along with compound statements. There's two different types. Basically, the compound statements are combining two statements using the words and, or. A conjunction uses the word and. So it's a compound statement using and. And then a disjunction is the one that uses or. So an example would be of a conjunction is you can go to the movie theater and buy popcorn and a drink. That would be a conjunction. And a disjunction would be the same thing while using or. You can go to the movie and buy popcorn or a drink. So we are going to do lesson practice